Hello, chemistry students. I just wanted to talk about the notes that we covered. This is on Monday and through mostly Monday, August 30th. And we're basically looking at a beaker versus graduated cylinder. In Schoology, there is a link for teaching slides, and it's going to cover. Look for those teaching slides, and that covers all of this right here, all the way down this whole page. Okay, so it's mainly talking about a beaker versus a graduated cylinder, that this graduated cylinder is better. You're going to be looking at how to read the graduations, and that there's like 10 here, 10 lines between 10 and 20, between 0 and 10, and there's 10 lines. So this would be an increment of 1 mil. And it actually talks about it in the slides and gives you these answers for these increments. And you're actually trying to read these increments so you can actually record what is measured if you're between 60 and 65, or here you're right above 79, and here you're right above 35. And this set of slides goes over it. Now, unfortunately, I was unable to load in my slides and work from a Google Meet today, so I'm trying to explain to use the teaching slides to cover this part. And then when you flip to the other side, it's not part of the slides, but I want you to kind of go through and also fill these out. This is what we covered a little bit on Monday, and we also covered it on Tuesday for some of the sections. And if we didn't cover it, because I was out part of Tuesday, then for periods 4 and periods 2, we're also going to cover it on Wednesday, just to go over. These are more like practice ones that we're covering, to go over how to read increments. How can you determine what each of these lines represents? Then you're trying to figure out what would these volumes be recorded to. And then down here, you're actually drawing a curved meniscus. That is the curvature of the liquid of water in a cylinder. And I was going to try to highlight, a couple of these, a couple here, and a couple here. Then the actual homework is another set of papers that are stapled, and these are the reading scales. So in the actual link in Schoology, you have these first 2 pages of notes, and then the next 4 pages are homework, and this is homework practice. And I'd like you to take eventually a quiz, to be prepared for a quiz, and I'm hoping to have the quiz on Friday, along with significant digit rules that I'm teaching. I taught a little bit today, and tomorrow. This is Tuesday and Wednesday. So there's a little bit of this on the quiz, along with a little bit of the next topic called significant digits. So I wanted to maybe go through a couple of these. Now, in the video that I did for Tuesday, I did go over a couple of these and these, and I'm not sure. I only have about 15 minutes on each of these videos using my document camera. So I'm only going to record to 15 minutes. I'm hoping I can get you, caught up with what you missed on Monday the 30th. Okay. So Monday the 30th, I covered all of this, and there are teaching slides that are on the same page as this video going over it. And the slides are there. Go ahead and try to fill in. And we're trying to have you understand that a graduated cylinder is a better measuring tool than a beaker when you get done with the slides. And then you're also trying to learn how to do these increments so that you can then read a volume correctly, okay? And so when we go to the second side, I'm actually doing more of these increments here. And I covered this for some of the classes today and tomorrow. So it's going to be covered, through the week. But if you look at here, you have a spaces, and this is all usually volume. You could also do this with a thermometer, a type of liquid alcohol thermometer. And here you have 5 lines between 1 and 2, between 0 and 1. So it's like you have 5 divisions for 1 mil. So you're going to put the 1 mil divided by 5 lines. So it's like saying, what is 1/5? And 1/5 is like saying every increment is going to be 0.2. This will be 0.2. This will be 0.4. This next line is 0.6. This next line is 0.8. And then you have a 1. So each increment is going to be a 0.2. okay? If we do a very similar thing with only having 5 lines, but it's 10 to 0, 20 to 10. So instead of having 1 over 5, we're going to have 10 volume units over 5 lines, and that reduces down to having each one being 2. This is 2, 4, 6, 8 mils. This is 12, 14, and so forth, and so on, all the way up to 20. So this would be 2 mils. Okay, you could have the same kind of space between 0 and 10, and you'd have 10 increments. So 10 units divided by 10 lines would make it come out to be 1 mil. So we're all basically talking about milliliters in a graduated cylinder, and this would represent 0.2. So that would be like 1.2. This would be 2.4, and so forth. When you have 10 lines in 10 mils and each one is 1. So this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 12, 13, 14, 15, and so forth. Now what happens when you only have 2 divisions with 1 mil? So it's like saying 1 mil divided by 2 divisions gives you a decimal of 0.5. So these are kind of like decisions you got to make when you read these in order to read them, okay? So let me do 1 or 2 of these here. I wanted to show you when you have 10 lines in between, you're going to literally call this 20, and then the next line 21, then 22, then 23, then 24, and then here we're at 25. And actually, as you read it, the actual reading is a little bit above 25. So you definitely have 25, and then you're going to go a little bit above it. So you're going to definitely put the 0.1. If it is exactly on the line, it's not quite here, but it is very close. If it was exactly on the line, then you would put 25.0, and you'll see that on some of the homework. And that's going to be, if I flip to the homework and you go to page 2, you're going to see that on this one, because it's directly on the line, on this one, so I would circle them. And then you would have this one going directly on the line. You're going to do the 0.0. It's going to be something 0.0. Also on this I, it's going to be something 0.0. So just to let you know that those are the 4 that apply to that, okay? Then when you have the same, now here you only go to a tenth because every unit is 1, but when you divide it between 4 and 5 and 5 and 6, then each line is like a tenth, like that's 4.1, that's 4.2, that's 4.3. So you're definitely going to be going 5 something, and then you go up 4 lines, you definitely know it's 4.5. And what I was showing in the video, in the slides, is that this is definite, but then this last number, the last value is always estimated. And it talks about it in the slides, but this last number is estimated. So we definitely know it's 5.4, but it's a little bit above 5.4, and that actual difference between them can be estimated and different amongst a lot of different people, because to me it looks like 0.6, so 5.46, but you also could do 5.47, you could do 5.48, and there's nothing wrong with that because this last digit is estimated, okay? So you try to work out the other two, because of time here, I don't want to go on forever, but you also could draw in these units. So here we have between 48 and 49, we have 10 units. So each line is a tenth. Okay, so it's 48.1, 48.2, etc., etc. So you're trying to go to 49, and then you're going to go up the 10th, 49.1. This is 49.2. So you're going to go a little bit above it to the next digit, because that's the estimated one. So you're going to estimate, try to draw a little bit above that line, not exactly on the line, but close to it. You see how it's a little bit above it. Okay, and it should be a little curved, but it's hard to draw that. Okay. Now, when you do this one, you got every line is 1. Here, now this is actually going to be, this is like 1 mil, 2 mil, 3 mil, 4 mil, 5 mil. But here we're actually getting into some tenths. But because there's only 5 units, then this is the 26.2. and this is like 26.4 because there's 5 units, but you're trying to go to 27.6 and you're just a little tad above the 6. So this is 0.2, 0.4, 0.6, so you're a little bit above it. Okay, and so you're going up that way, and that's going to be your answer for that. Anyway, so you try and do the other 4, and I can send me a picture. Send me a picture, and I can tell you if they're right or not. Okay, let's go ahead and look at some more of the homework. When you look at this, and I don't know how much I covered, I did cover a little bit of it at the end of the video from the 31st, from Tuesday, just because I wanted to kind of go through some of the homework answers. I also posted the homework key on this same page. So you can try to do some of these and then check the key. Now these two are very close together. So I have a couple more minutes to go over here, but I don't want to go on and belabor every single one. But these are very similar. It's just that this has no lines in between. So when you do this, you can definitely know it's 8. But the next digit you're going to estimate. So I'm going to leave that blank for a minute, but compare it to the next one because this is 8, but you have totally a whole bunch of lines, so you know it's past the 9. So you can say 8.9 for sure, and it's this next one where you're not so sure. Okay, so here, when you do this, you definitely know it's 8.9. This is estimated because you don't have any more divisions, but here you have it. You definitely know it's past the 9, so it's going to be 8.9, and now you estimate in between, it could be a 5, okay? So then we have this next one where there's no divisions again. We also have it down here at number 6, no divisions again. Here we do have divisions, and so you actually can go in between. You have to account for this number and this number, figure out what the divisions are, and try to come up with what it is. Now, here you're going to have a lot of numbers, and then even this part, we're going to learn what this means on our next lesson. So we're going to leave this column blank for now, okay? But later on, I will go back and give you the answers to what that is once we learn it, because they kind of go together, reading a measurement and then understanding significant figures. Okay, now when you come down to these, like this one here and this one here and this one here, this is a really large number. You're in the thousands, but you only know it's between 1100 and 1200, so you definitely know the 11 is for sure. It's just the next digit. It almost looks like it's a little further on, and it's definitely like at least 2/10, so you can definitely say it's a 1120. So this part is estimated, and you don't have any numbers here. You don't know what that is because there's no more divisions here to help you out. So this is going to be a 0 to show how big the number is. Only these 3 numbers are considered measured. This one's not, okay? So then we do another couple here that are smaller, and you definitely are between 0 and 0.1. We have 10 divisions here, and so you have to go and you have 6 here, but since it's less than 1, it's not 0.1, it's going to be 0.06. You definitely know that, and then the distance between those can be any number in between because it's estimating in between. You can make that a 5 or a 4 or whatever, okay? If we do one more, take a minute, see what you get with that. You definitely know it's less. It's a 0.02 something, and you're 5 units away, but you're almost actually at the 6th unit. So tell me what you think it is, and it's exactly at the 6th unit. So tell me what you're going to need. You're going to definitely have 0.002, but you're going to put something and something because you definitely have this 6th line, and it's exactly on the 6th line. So you're going to take a minute, write that down, and it would be actually, and then now I'm going to tell you the answer, 0.0260, okay? Now, on the other pages, you've got some temperatures where you're going to go below 0. You're going to go down here because it's below 0. Also going down here because it's below 0. But here you're going to read up, read up, read up, exactly. So you try to work on more of these, and I'll post the answer key. Okay, I got to go now. The time's running out. It's 15 minutes. Okay, let me know what your questions are.